In state trees, the way that logic moves from one state to another is through transitions. And understanding how transitions work allow you to create simple or complex state trees where you can control and predict exactly how logic will move from one state to another. This is one of the biggest advantages of state trees over behavior trees. In our current example, where we've created a state tree to control the opening and closing of a door, we have also created some transitions in order to test it out, and we've looked at a few examples. In today's video, we're going to look more in depth in the different transitions that are available and how they can be used to have absolute control over your state tree logic. I've updated this project to Unreal 5.6 because some bugs have been fixed and a new type of transition has been introduced. In our current example, we have to pick up a key before we can open the door. So without it, we get an alarm, but we can automatically pick up a key and then the door will open. In order to understand transitions, what we will do is we will add a state tree to our keycard. And I've created a state tree like this. The way that our tree is set up is that it will first transition to a state where it waits for the player to overlap its collision box. Once the player overlaps, we will show a widget asking the player if it wants to collect the card by pressing E or to decline by pressing X. If the player chooses to collect the card, we'll transition to the card collected success state, and then we'll transition to the destroy card once we've added it to the player's tags. If the player declines to collect the card, we'll transition to the card collection fail state and then transition back to the state where we wait for the player to overlap again. In earlier videos, we've learned about how to set up schemas, which here will be the context actor of the BP keycard. There will be a parameter. I've created evaluators, which we've looked at in previous videos as well. And the evaluator will tell us whether the player has overlapped the keycard or not. And I've added the state tree to the BP keycard as a state tree here. And it has a keycard tag, which we can set so that it corresponds to the correct keycard we want to collect. The state tree evaluator, which is SDE keycard, will set this variable player begin overlap. And basically it will just bind to the on component begin and end overlaps and set the variable when the player overlaps the keycard and unset it when they end their overlap. And this box here is the overlap box. So let's start looking at transitions. So when our state tree begins for the keycard, it will begin at the root and it will follow the selection behavior. And so it will select the first child it can enter. And the first child we have is this state. And because there are no enter conditions, it will automatically enter this state, where it will wait for the player to overlap. When our player overlaps, our evaluator will set this variable, player begin overlap, to true. We can then use that variable to trigger a transition from this state to the next state. So if we click on the waiting for player to overlap state and we go to the details, over here at the bottom you have transitions. And if you click on the plus, you can add a new transition. And the transition will have three things available. So there is a trigger to trigger that transition. There is a transition to where you can set the state it will next transition to. And then there is the option to add conditions. And these conditions have to be met in order for the transition to be triggered. If we click on trigger itself and go down to the drop-down menu, there are a number of different options available, and each one of these works slightly differently. What we will do is we'll try to work through examples of each and every one. We'll begin with the on tick. So this will try to trigger a transition on every tick, as it says in the tooltip. So we'll click on that. We can then set the state we want it to transition to. which will be the ask player if they want to collect the keycard. We can set a priority, so if multiple transitions are being triggered at the same time, the one with the highest priority should go through, but we can leave that at normal in this example. There is also an option to have a delay transition. So once the transition has been triggered, the state tree will delay for a certain number of seconds based on the delay duration before it actually triggers the transition. And then at the bottom, we can add the condition or conditions that must be met, as you can add multiple one of these. And in our case, we want the condition to be that the player begin overlap is true. So we can click on the Add New Transition condition, and we can go down to a Bool compare. So there's lots of different options available here, and we've done previous videos on conditions. So we'll click on the Bool compare, and we want to check if the Boolean that is coming in, which is the player begin overlap, which we can get from the evaluator player begin overlap, is equal to true. So if this condition is met, we will transition to the next state. And the state tree will check on every tick whether that condition is being met. I've added a task to this state. All it does is it shows some debug information. And technically, you don't need to add a task to a state. It will still function without that. But we can now go and check to see whether this transition is checking on every tick for the condition before it transitions to the next state. So we go back to our main editor, and if we press play, in the top left, there is the debug information of what task our key currently is in. So it's waiting for player overlap. And now when we walk towards it, an overlap, we now get the widget asking us to press E to collect or X to decline. And in the top left, you can see we're now in state tree ask player to collect state. So that transition is correctly waiting for a change in the variable and checking on tick before it transitions to the next state. Like all things that check on tick, it all depends on how complex the conditions are, whether it has any performance issue or not. As we saw in our update video on Unreal 5.6, they have added the ability to set a custom tick rate to transitions and tasks. So up here in the details panel for your state tree task, there's the option to set a custom tick rate, which can be used to control performance issues. And that is based on the schedule tick policy, which can be changed as well. But that's a very simple way of setting up a transition trigger rule. Once we transition to the ask player, if wants to collect card state, we then need to decide whether we need to transition from there to the card collected success if they press E, or the card collection failed if they press X. So if we go to our state here, and we open the task which is running on it, which is the ask player to collect, and we open that. And the way that this is set up is it creates a widget to show, and it just binds to the events based on whether the player presses E or X. And those bindings will then trigger one of these two events here. And based on which one is triggered, we can then tell the state tree to transition to the next relevant state. So if we go back to the actual state tree itself and go to the state here, and we go to the transitions, and let's look at a different way of pulling this off. So the default option is on state completed. And state completed, state succeeded, and state failed all go together. In other words, state completed means that this will trigger if a state succeeds or a state fails. So that can be a catch-all for when you add a finish task node. However, you can break them down into the individual options. So let's look at how using state completed can be used to trigger the correct transition. So I'll click on state completed first. And what we will need to do is probably have two transitions with different conditions so that we then transition to the correct state based on which key is pressed. So one of our transitions will be to the card collected success. And then we can add another transition, again on state completed, and this one will be to the card collection failed. Now we need to decide what these conditions will be. So if we go back to our task by clicking here, I've created a variable called key collected. So if the player presses the E key and the player wants card is called, we can set key collected to being true. If they decline the card, we can set key card collected to false. And then we can call the finish task node. And we can do this on both of these events. Now in state completed, as I said, will be called whether this is succeeded or failed. So whether you tick them or not, as long as you call a finish task, it will trigger the state completed transition trigger. But what we can do is we can use this variable to be our condition. So back in our state tree, on collected, go to card collected success, we can add a condition. That can be a bool compare. And this time we can bind it to this key collected parameter. So left in, go to our task, key collected, and say, if it's true, go to card collected success. Here we can do exactly the same. Bool compare, go to st player collect key card collected, but leave that as false. So if the state completed is triggered, it will look to see whether the key collected variable is true or false, and then trigger the correct transition. So we can compile that and save it. We can now test out this transition. So if we play, and if I run towards the key card, and I get the option to press E to collect. So if we look in the top left, when I press E, it should say state tree card collection success, and the message key card collected comes. We play that again, and I now go and this time if I press X, we get the message declined key card, and in the top left we get the debug card collection failed task is running. So those transitions are being triggered correctly based on the rules that we have set up, and that's using onState completed. But what we might want to do is have an onState success and an onState failed. So if we just delete these, compile, and this time on the transition, we will choose onState succeeded, tell it to transition to card collected success, put in another transition, and this time say onState failed. And this will go to card collection failed. We can compile that, go back to our task. And this time what we will do is when the card is collected, when the player wants the card, we'll do the finish task succeeded true. And if the player declines collecting the card, we will just set the finish task with a failed, so with the succeeded unticked. So we don't actually need these two variables here in this setup, because we're just using the onState success or onState failed as our trigger in the state tree. So again, that should work the same as it did previously. So if we go back to our editor and we play, if I go to the keycard and if I press E, we get keycard collected with the debug message. And if I go replay and this time press X, we get the declined keycard with a card collection failed debug message. So that's how you can use state completed or state succeeded, or state failed. And on each of these, you could add a condition, as you could have multiple of these in your actual transition rules. And the way that they are evaluated is from the top down. So the one above does take precedence on the one below, and that is why the conditions can help you ensure that the correct transition is being triggered if you have multiple of them. So our state tree can now transition to the card collected success or failed based on these transition rules. But once it goes to the card collected success, we then want our state tree to add the correct keycard tag to our player so that they can open the door, and then transition to the destroy card state. So if we click on our card collected success state and look at the transitions that are available. So we've looked at state completed, succeeded, failed, and tick. And this time we're going to look at on event. And on event is one of the most powerful transitions available in state trees, and probably the one that you're going to use most often, because not only can you use it in your state tree tasks, but you can also use it externally to trigger transitions in your state trees. So I'm going to click on event. Just like previous transitions, you have a transition to state, and this one would be our destroy card. You can set a priority, a transition delay, and add conditions. But you also have the required event menu item here to set up as well. And generally, events are triggered by gameplay tags. You can also send payloads and decide whether the event is consumed or not. And we've looked at payloads in a previous video, as these can contain a lot of extra information. But what we want to do is to set up the tag that will trigger this event. When you send an event to a state tree, you must either give it a tag or a payload, or both. Because if you leave it empty and you compile, you will get an error message saying that the event transition requires at least a tag or a payload to be set up. So I'm going to click on the tag, and I've created some tags already for our keycard, and one of them is keycard.destroy. So the way that this will work is, if we send an event to our state tree when we are in this state with the tag keycard.destroy, it will try to trigger the transition to the destroy card state, as long as there are no conditions preventing it from going through. We can compile our state tree again, and now we can go to our task for this state by clicking here. And the way that this is set up is that once we enter the state, we will get the third person character and add the keycard tag to the player so that they can use it to open the door. And at the end of this, we will then send an event to the state tree telling it to trigger the transition to the state that will destroy the card as it has been picked up. And the way that we do that is by using a send state tree event node. So if we do type in send or state tree send event, we will get this node. And this node requires an event. So we can either drag off from the event and say make state tree event and enter the details here, or we can just right click on the event and do split struct so it's all in one node. And we want to send the event with the tag that we chose, so keycard.destroy. We can attach a payload like we showed earlier, and we can also give the name of the event origin so it can be identified where the state tree event came from. But essentially we want to connect these two things up. We don't need to do a finish task node on this state because this event is what we are using to trigger a transition. So we can compile that, go back to our state tree, And if everything works, it should transition and destroy the card. What we can do is maybe put in a little delay here so it doesn't destroy it instantly. Compile, save, go back to our editor. And when we now play, and we go towards the key, and we press E, after 3 seconds it should disappear. And so it's being destroyed. If you'd seen the debug message in the top left, we've now entered the state destroy. As I said earlier, an event can be called from anything that has access to the state tree reference. So this can be within a task, it could be an evaluator, but it can also be from the keycard itself, because the keycard has a reference to the state tree. So we could drag off the state tree reference and say, send state tree event. And again, we could send the same state tree event from the actual keycard itself. We could put in a little delay and then attach everything up. However, if we were to run this, it would not actually work. So if I press play and I wait for 2 seconds, the event has been sent, but the keycard still remains. And that comes down to how transitions work on state trees. Essentially, a transition will only trigger when you are in that state or in one of its child states. So if I added a child state to our card collected state, in which the transition on event exists, whether I'm in the card collected state or the child state, it will still trigger. However, if I'm in any other state, sending this state tree event to the tree will not trigger it, which is why the destroy card did not trigger when we sent it from the key card, because we began up here and we're not in this state. However, if we were to add that event to the root state, it would then trigger regardless of which child state we were in. So if I put it here, on event, choose the event again to be our keycard destroy, and to transition to destroy card. This time after 2 seconds, it should destroy the card. So if we play, give it 2 seconds, and the card is destroyed. So that's an important thing to understand, is that all of these transitions that we are adding only apply when we are in that state or any of its child states. So for instance, if I wanted to have an auto-destroy on my card, but only have that card auto-destroy itself after a set number of seconds, if we were waiting for the player to overlap, but not if the player had overlapped and we were waiting for input, then I could set up a task like this called state tree auto-destroy, give it an auto-destroy time, let's just say 3 seconds. And if I only want it to be something that can be triggered when we're in this state, I would add the actual trigger transition to this state. So I could add another transition, exactly the same, go to destroy card, key card, destroy. And I can remove this one because we don't need it. So now this task, which will auto-destroy the card, will only auto-destroy if we are waiting for the player to overlap. Once we go there, in those 3 seconds, it should not destroy. So we go, we play. If I don't go to the card within 3 seconds, the card is destroyed. On the other hand, if I play and I get to the card within 3 seconds, then the card will not auto-destroy because we are not in that state where it can be triggered. As a rule, try to put your transitions on the state that you want the transition to be triggered from, rather than always putting them on the root or the parent states. However, if you want a transition to be triggered regardless of which state the tree is in, then you can just put it on the root, as that will apply to every single state and child state. So our card collected success state will successfully transition to the destroy card state. Now we can look at the card collection failed. What we want this state to do is to transition back to the waiting for player to overlap. So if we click on the card collection failed state, and what we can do is we can go straight to the task, because we'll look at a different type of transition that is now working in 5.6. So I'll click on that to open the task. And this is the event enter state, because before this state goes back to the wait for overlap, it will need to turn off the player is overlapping Boolean that was set by the evaluator. And I'm doing that using property reference nodes and parameters. But once that has been done, we can then use the state tree request transition node. So if you right click and type in request transition, we get the state tree request transition. And we can use this to request that the state tree transitions to a different state. So we have a target state here. Unfortunately, when you click on it, you cannot split the struct, or if you go to make struct, again, there is nothing to set. However, if you promote this to a variable and compile, when you click on the target state, there is the option to set a target state. However, there is a bit of a bug in 5.6 in which the target states don't appear in the task itself. However, if we expose, by making this visible, the target state variable, compile, go back to our state tree, go to our state, and on the task, we will now have access to a target state variable that we can set. And from here, we can actually choose the name of the state we want to transition to. So our state is waiting for player to overlap. And we can compile that. And this is the Boolean property that we set before we make the transition, which will set this value here. And then the evaluator is also checking for that value and resetting it. So here's a quick look at how that happens. So that's on the event tick, property reference, and it is resetting it once it has been set. Otherwise, if we didn't do that, the moment we went back to the waiting for player to overlap, we would transition into the next state. But if we test this, what should hopefully happen is, once we collect the card, we send the state tree request transition, and we will go back to the waiting for player to overlap. So we go back to the editor, and we play. So I go to the keycard, I press X this time, it says declined keycard, and then we go back to the waiting for player to overlap, as you can see in the debug in the top left, which means that we can come back, we can collect the card again. And after a few seconds, it will disappear, and we can open the door. So this state tree request transition is another way of transitioning. And again, you don't need to set a transition in the actual state tree itself, but just request it in the task. And as long as there are no conditions blocking it, it will try to go through. This wasn't working in 5.5, but is now functioning correctly, except for this issue here. So the last type of transition we're going to look at is a new type that has been introduced in Unreal 5.6. So if we go to our destroy card, go to transitions, the new one that has been introduced is the On Delegate. So this will trigger a transition on a state tree delegate. And if you've watched the update video I did on 5.6, you will see that there are On Delegates and On Listeners which have been introduced. But we're going to look at the On Delegate approach to trigger a transition. When we enter the destroy card, instead of destroying it straight away, what we will do is we will play some animation and then at the end of the animation, we will destroy it. So we will create two states, which will be child states of the destroy card. One will play the collected animation, and the other will destroy the card. And what we'll do is we'll remove the task that is on the actual destroy card from here. So we can delete that. And we'll delete this transition. That was just for show. On the play collected animation state, I've created a keycard collected animation. And then on the destroy keycard state, we will add the task destroy card. So what we want to happen is when we enter the destroy card state, we will automatically go to the play collected animation. Once we've played that animation, we will then transition to the destroy keycard. So if we go to the play collected animation and we add the transition on delegate here. So the trigger will be on delegate. The transition will be to the destroy keycard. And again, we now need to provide a delegate to bind to. So we can go to the actual task keycard collected animation. And the way that this is working is that I've created an actor sequence in the keycard, which will essentially just play a sequence for us. And once it's played the sequence, we then want to have a delay and then trigger the transition. So the sequence is about one second in length. So maybe put a delay for slightly longer than that. And then we want to use the on delegate. So how do we create a delegate? If we go to our variables and create a new variable, and we can call this our delegate animation finished. And then we go to the drop down, and if you type in state tree delegate, you will then get access to the two new options available in 5.6. So there is a delegate dispatcher and there is a delegate listener. And if you want to see how the two interact together, do watch that video that I did. But all we need for this particular transition is the delegate dispatcher. So we can create that and just make it visible. Then in order to actually call that delegate, much like event dispatchers, we can drag it across, get the delegate, and there is a broadcast node, broadcast delegate. So this will broadcast the delegate, and anything that is listening to this delegate will then be able to act on receiving that broadcast. So we can compile that, go back to our state tree again, and now we should be able to bind to this delegate in the transition. Keycard collected animation state task, and there's the delegate animation finished. And when that's triggered, it should go to the destroy keycard. And all the destroy keycard task does is it has a bit of a delay and then it destroys the actor. So if we go back to our third person map, we can now test everything out. We press play, we go towards the keycard, we press E to collect, we get the message, we get the animation, and then it's destroyed. So that shows us that the delegate is actually working. And if we go there, press X to decline, card is declined, we can go away, and then we should be able to go back, try again, press E, should get the animation, card is picked up, we can go through, and our door will close after us, just like it was in our previous videos. And we can keep opening and closing it. So I think I've gone through all the different types of transitions that are actually available in state trees. So if we look at them again, I think we've done completed, succeeded, failed, tick, event, and on delegate. And we've also looked at the state tree request transition approach. You probably won't use all of these transitions, but each of them has their pros and cons, so it's worth knowing about them, because there may be unique cases where one is preferable to another, even though you'll probably end up using one or two of them for the majority of your logic. I hope that helps explain how transitions work and the different types that are available in Unreal state trees.